Oh, man. 3.2. 4 ways to prove triangles congruent. The moment you've been waiting for. You've been, past me in class. Say, hey, Mr. Allen, I've had so many times where I need to prove triangles that are congruent in real life, and I just don't know how to do it. Could you please show me? And now I'm finally going to give you those life tools to do so. I'm going to show you how to do this, so that way when you're asked in a job interview, hey, we love you, you're great, we would love to offer you the job, but can you prove these two triangles congruent? And you're going to say, you know what, as a matter of fact, yes, I can. Look at that. You are welcome. All right, so first one, side, angle, side, abbreviated as SAS, is what you see right there in the picture. So we've got the order, by the way, very much matters. Side, whoop, then an angle, then another pair of congruent sides. So it's side, then angle, then side. The angle is between the two sides, as you see here in the abbreviation. Lovely. All right, the next one, side, 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 meaning all three pairs of corresponding sides are congruent. So we got these two with the double tick. But then where's my third one? Oh, wait, reflexive property. Boom, side, 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 America. Angle, side, angle, meaning I've got an angle, pair of angles congruent, pair of sides congruent, and then, ooh, where's my other angle? Well, my other angle would be right about here. Ooh. Well, that was just absolutely terrible. Let me see if I can try that again. Perfect, I like it. Ooh, I should probably put an extra tick mark on those. Very good. So we got angle, side, angle. This time the side is between the angles, as you see in its abbreviation. And the last one here on this page is angle, angle, side. So I've got an angle, pair of angles, another pair of angles over here and here. And then where's my side? Ooh, reflexive. Notice how when we're using reflexive, it's because the two triangles share the same side, or they might share the same angle. It works for both. We often see it with sides more often than angles, but it can happen with angles. But notice how these two triangles are sharing the same side. Reflexive property is very, 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 very commonly misused, so be careful with it. So we often think that angle, angle, angle is a postulate that would prove triangles congruent, and it is not quite the case, okay? I think about angle, 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 not in the context of triangles so much, but I think about it almost more of like rectangles. Imagine if you take a picture that's like a rectangle in shape, and you enlarge it. You still have 4 right angles, but are those things the same size anymore? No. And the same concept holds true with triangles. I could have a triangle like this, and then I can have a far larger triangle, one that I just changed the overall size of to, it's still the same angles. Let's see if I can actually draw one like this, and let's see if I can actually enlarge it. See if this thing gets fancy with me. Okay, oh, no, the whole thing just goes, oh, well, there you go. See, same idea. This triangle, same angles every time as I do this, right? Same angles, but my side lengths are increasing as I enlarge the triangle. All right, that's wonderful. All right, do we throw up? Hopefully not. Okay, moving on. So what I would suggest you guys do here is pause this video and see if you can figure out which postulate will prove these triangles congruent. Okay, so we're going to practice a few of these, and then we're going to do some proofs. So pause it, and then I'm going to go through the answers. Alrighty, so in this one we've got side, angle, side. Notice how we have the sides with the angle between the two pairs of congruent sides. Alright, this one here, if I use reflexive, I got side, side, side. Two triangles are congruent by side, side, side. How about the next one? Ooh! Vertical angles are congruent. Heck yeah! So I've got angle, side, angle. Now this next one might be kind of tough to tell. I'm going to outline the two triangles in different colors. So I've got this guy. They overlap. That's fun. And this guy. We'll go with those two. Well, how are those congruent? Well, in the green one, I've got this angle, and I've got another pair of angles. I don't like that we only have one tick mark on there, so I'll put 2. And then the blue one, I've got this angle, and of course this one up here. And then it looks like I've also got that side there. Let me mark the green one. So what I've really got going on here is angle, side, angle. Okay, angle, side, angle. America, freedom, rock and roll. Go. Oh my goodness, another 6 more. So again, pause it, and then hit play when you're ready to go through the answers. Alrighty. Let's do this. So the next one, ooh, okay. Number 5 here. Some of you might have said side, angle, side. Well, in order for it to be side, angle, side, this would be the angle that has to be, the pair of angles that has to be congruent, and that is not the case. And some of you might have said side, side, angle, or angle, side, side. Now, that actually does not work, okay? Only in a special case, which we'll deal with, I think, in a couple days, or tomorrow. I can't even remember. America. All right. So this one, we cannot prove congruent. All right, we cannot prove. That's a fun marker. All right, so it cannot prove that those two are congruent, and here's why. I could redraw this side right here. I could redraw that guy with the same length, but on a different angle, making a whole new triangle. So this could be the same length right here. I did not change this angle here in doing that. I didn't change this side length when doing that. All I did is I took this guy, and I like to think about it as like I swung it in and set it down. And now it's a whole different triangle that does not look to be congruent to that one. All right, so we cannot prove that one. We'll talk about that more in class if you're still a little confused. That's a tough one to grasp. All right. Next, we got this guy here, a little reflexive property. Is going to give me a little side, angle, side action. I feel like side, angle, side is probably the most common one. It just always seems to come up. Alrighty, M is the midpoint of A, B, and CD. Well, if M is the midpoint, these two are congruent. These two are congruent. And I've also got myself some vertical angles already in there. So again, SAS. Alright, the next one. It says angle 1 is congruent to angle 2. BC and CD are congruent. All right. I know that AC is congruent to itself. So then, what have I got here? Well, if 1 and 2 are congruent, I could go through like supplementary or something like that, and get subs of congruent angles are congruent to get those two congruent. But now what? Looks to me like I've got a little bit of a angle side side or side side angle. That can't be proven, right? Nope. Can't prove it. All right. Let's keep it moving. Let's keep it grooving. America. This one over here. Little reflexive property gets me angle, side, angle. And lastly, I've got myself some side, angle, side. Awesome. Alright, if you have any questions on these, please, please, please ask in class, because this is the foundation, the building blocks of this, basically the rest of this, whole semester or more. So we just continue to work with congruent triangles throughout basically the entire rest of this semester and half of the next semester. Congruent triangles are in almost every single proof that we deal with. Very rarely are they not. So knowing how to prove triangles congruent is very important in the context of this class, but you will get plenty of practice with it. So not a proof yet. We'll do a proof here shortly. I know you're chomping at the bit here, but it says if GH and KO are congruent, and angle G is congruent to angle O, what is still needed to prove that the two triangles are congruent by side, angle, side? Well, if I want side, angle, side, what two segments would need to be congruent? That would be GJ is congruent to OM. I want you guys to pause it, try the next two, see if you can get it, press play, and I'll give you an explanation. All right, how about angle, side, angle? Well, in order to do that, I would need angle H is congruent to angle K. Then I would have an angle, a side, and an angle, where the side would be included between those two angles. All right, next one. Angle, angle, side. Ooh. Well, if I had J and M congruent to each other, I'd have angle, angle, then a side, right? Angle, angle, then a side, angle, angle, side. That's what we got. So angle J congruent to angle M. Are those right angles? Not necessarily, right? We don't know that. We don't know if J and M are at right angles. We can't assume that, but we also can't say that they're definitely not, because we don't know. Okay, so let's try a proof here. Look at that, a real-life proof, because it's a butterfly. We can prove its wings that are kind of almost triangles, but not really, are congruent by drawing letters on it. How exciting. All right, so G is the midpoint of FH and EI, and I want to prove those two triangles congruent. Well, if G is the midpoint of FH and EI, what do we know? Well, I would know that these two are congruent, and I would know that these two right here are congruent as well, those two segments. Okay, well, if I've got those congruent, all I need is either, and this is the way I like to think about with triangles and proving triangles congruent, either I'm going to need to get FE congruent to HI, or I'm going to need to get these two angles congruent, so I can either do side, 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 or side, angle, side. The other angles wouldn't be helpful, because then I'd have angle, side, side, or side, side, angle, and we don't want that, okay? You don't want angle, side, side. It don't work. So, I'm thinking we all just saw that, but our vertical angles here, whoop, those two right there being congruent, I've got side, angle, side. Let's write it up. So we've got our given. I'll draw myself a nice little arrow. All right, next up, I've got FG is congruent to GH. And then I've got EG is congruent to GI. Oops, that's an H. And that's by midpoint. Midpoint definition. I'm going to put def midpoint. Def midpoint. Somebody is printing to this room. I wonder if you can hear that in the video, because I certainly can. Now, a question you might have is, do I need two separate steps since it's using the same definition? In this case, no. And the reason being is, well, does FG, actually, you know, I'm going to use a lightsaber on this one. Okay, here we go. Check out this cool pointer. FG and GH being congruent has no bearing on whether EG and GI are congruent. Okay, so I can put them in the same step because one doesn't follow from the other. They can be flipped around, so since they use the same reason, I can put them in the same step. Next one. I've got angle FGE is congruent to angle HGI, and that would be our vertical angles congruent. Woo! Do I have enough to prove these triangles congruent? Heck yeah, I do. I'm running out of room though down here. Alrighty, here we go. So I have triangle FGE is congruent to triangle HGI. Sorry, everything is kind of crammed here, guys. I should have adjusted, but I didn't. YOLO. And our reason is SAS. Side angle side. Alrighty, excellent. And notice how my corresponding parts line up. FG, and HG are my congruent segments, right? And I have, let's see here, GE and GI, GI are also congruent. And the angle with the vertex of G, those guys are also lined up in the same spot. Again, another thing I want to point out, we couldn't just write angle G is congruent to angle G, because which one's angle G? There's like 4 of them, 8 of them, a million of them. Who knows? All right, so we got multiple angles with the vertex of G, so you do have to use the 3 letters here. Awesome. Look at that, our first proof of congruent triangles. The first of many, really, on a long journey of excitement. Alrighty, last one for the day. I know you're excited about that. So I've got AC is perpendicular to DB. I've got angle B is congruent to angle D, and I want to prove the triangle is congruent. Let's do it. All right, I'm going to mark down my congruent angles, D and B. Awesome. I know that AC is perpendicular to DB, so what does that give me? Right angles. Woo! What do I know about all right angles? Oh my goodness, they are congruent. I've already got two angles that are congruent. I need a side. Any side will do because it can either be angle, side, angle, or it could be angle, angle, side. I've got two angles. I need one more side. It needs to be somewhere. So my options are really any pair of sides. Are DC and CB congruent? I don't know. Are AD and AB congruent? I don't know. Is AC congruent to itself? Heck yes. Reflexive property. YOLO. Awesome. Swag. Let's write it up. I've got congruent triangles. That was like a power proof right there. Boom. So we got right angles, right? Angle ACD and angle ACB are right angles. I don't know why Siri just went off on me. You might have heard that. All right, that's definition perpendicular. 3. I know these bad boys are congruent, right? Why is that? Well, all right angles are congruent. If you decided to go the route of saying perpendicular tells you 90 degrees, then you'd be using definition of congruent here. But we said that they're right angles, so all right angles congruent. Awesome. I'm going to move this bad boy up a little bit. Whoop. Next one. I got to get my reflexive property on. AC is congruent to AC, congruent to itself by reflexive property. The reason why I can use that here is that both triangles are using side AC. So if I say it's congruent to itself, it's like I get a free side of congruentnesses for the two triangles. And lastly, my triangle proof, ACD, ACB. And that was angle, angle, side in this case. Awesome. Right, guys? Angle, angle, side. Angle, angle, side. Angle, angle, side. Angle, angle, side. Yes. All right, your H-dubs for tonight is page 122 to 16 evens. America.